I accidentally stopped the video, so this is a new video. So we're going to combine, just as we did up here with the trig one. This is a chain plus a quotient and a product. We're going to do it, but we're going to do it with no trig in this one. So if our function is x squared times the root of 1 minus x squared. Okay, so first of all, you don't want square roots when you're doing derivatives. So I'm going to rewrite this as x squared 1 minus x squared to the power of a half. And now you can see it's two functions being multiplied together. I'm going to call this u, and I'm going to call this one v. So we have to use product rule. Product rule says u primed times v plus v prime times u, or whatever order. It doesn't really matter for product rule. So u primed, what's the derivative of x squared? That is going to be 2x times v, which is this function here, to the power of a half, plus v primed. Now, if you want, you can go over to the side and do this. If v is equal to 1 minus x squared to the power of a half, then v primed is going to be, use chain rule, drop the 1/2 down, take 1 away, so you get negative 1/2 times the inside derivative, which is negative 2x. That will simplify because that 2 and that 2 cancel out to negative x 1 minus x squared to the negative a half. That's v primed. So that goes right there. So which is going to be right here. So I'm going to get negative x 1 minus x squared to the negative 1/2 times u, which was just x squared. Okay? Calculus is over now. This is what JM was talking about. Calculus is 1 or 2 steps, and then it's a whole bunch of math to simplify and clean it up, which is important because this doesn't give us a lot of information. Like you said, in curve sketching, you need to have a simpler form to be able to pull information out of it. Okay, so let's clean this up a little bit. First expression, I can't really do anything with. Second expression, I can combine these x's and get minus x to the power of 3, 1 minus x squared to the negative 1/2. Okay, now we're going to start simplifying this. So the first thing is you'll look for common factors. Well, the obvious one that most people will see would be an x, right? I can pull an x out. The second obvious one, though, is the 1 minus x squared. Now, that's power of a half, that's power of negative half. We're going to go back for a sec, just to refresh your memory. If I have x cubed plus 2x squared, and I say take out a common factor, everybody's going to say it's x squared, and you're left with x plus 2. What you have to think about is you're factoring out the lowest exponent. All right? It's the lowest exponent that comes out. It's the same thing if they're fractions. So you look at them, if they're fractional exponents. You look at them, what's the lower exponent? It's negative 1/2. So that is what gets factored out. So along with the x comes a 1 minus x squared to the power of negative a half. And put a big bracket. Those are my two common factors. Now, the 2 is still there. I didn't do anything with that. This x came out, it's right there. And this is where you got to do a bit of thinking. 1 minus x squared to the power of a half. I took out 1 minus x squared to the power of negative a half. If we go back to this example here, when you factor something out, when I take out an x squared, to get what's left in the brackets, what you do is you actually divide by what you took out. Nobody ever thinks of it that way, but that's what you're actually doing. Okay? Which means you're subtracting the exponents. 3 minus 2 gives me power of 1 there. 2 minus 2 gives me power of 0, so I could write x to the 0, but nobody does. So that's what you have to do over here. Off to the side or in your head, just take the exponents and go 1/2, this one, subtract what you took out, -1/2. 1/2 minus -1/2 is 1/2 plus 1/2, which is 1. So I get 2 times 1 minus x squared to the power of 1. Minus, there was an x cubed, I took an x out, so there's an x squared there. And this whole thing is actually what's on the outside. So this goes away. So that's what's left inside the brackets. That's going to take some getting used to, but once you get the hang of it, you'll be able to do it quickly in your head. You need to practice, people. So now I've got x times 1 minus x squared, -1/2. I'm going to simplify the expression in here. I'm going to dump the 2 in, so I get 2 minus 2x squared minus x squared. Negative exponent, I'm going to drop to the numerator, or denominator, sorry. X, it's all going to be over 1 minus x squared to the power of 1/2. Inside this, I can collect my like terms, so I get 2 minus 3x squared. And that is the simplified version of this. I mean, you could write the square root of 1 minus x squared in the denominator, but that's what I want. I want it to look like that because, as JM said, if you're looking for x-intercepts or anything like that, or maxes and mins, it's what makes the numerator equal to 0. We will talk about that later on, so we don't need to worry about it right now. But this is the factored form, and it gives you a lot of information. It tells you where there's a vertical asymptote or a POD or whatever. All right, let's do another example here. Do a quotient. One where you sort of have to use a quotient. 2. I'm only doing a couple examples. So we're doing the derivative of this. 3x minus 1 over x squared plus 3 all to the power of 2. So there's a lot going on here. There's an outside function of the 2, power of 2, and then the inside function is actually a quotient. So the first step, we have to use chain rule, which says do the derivative of the outside. So I drop the 2 down, and I get 3x minus 1 over x squared plus 3 to the power of 1 times, and I'm going to write the derivative of the inside. I'm just going to say this. Now, normally I wouldn't do this, but this is what I'm going to do. So, and the inside is going to be this. Okay, so this is the outside derivative. Now we have to do the derivative of the inside. Derivative of the inside is a quotient. Okay, you can do it with the product by flipping it up, but I'm not going to. I want to practice quotient, just even though sometimes you don't want to do that. Use quotient rule. Sometimes we need to know how to do it sometimes. So, okay, quotient rule is, remember, we're going to break it up. There's my u, there's my v. Quotient rule says u primed v minus v primed u over v squared. Okay, so the derivative of this whole thing becomes, well, let's do u. U is equal to 3x minus 1, so u primed is equal to 3. V is equal to x squared plus 3, so v primed is equal to 2x. Plug it into your formula. U primed, which is 3, times the denominator, v x squared plus 3, minus v primed, which is 2x, times u, which is 3x minus 1, over v squared x squared plus 3 all squared. And what's it? So that's the derivative of this bit, but you have to remember this has to follow it down because that's part of the question. So in front of it, I write 2, 3x minus 1, over x squared plus 3. There we go. All right, calculus is over. Now we got to clean this up. So ignore this for now. Separate it with brackets. I need to clean all this up. The numerator, I can dump the 3 in, dump the 2x in, we can collect like terms. Do not mess with the denominator. Leave it in factored form. So I get 2 times 3x minus 1 over x squared plus 3. This 3 is going in here. So I get 3x squared plus 9. This goes in here. Minus 6x squared plus 2x. And it's all over x squared plus 3 all squared. Uh, 3x squared minus 6x squared is negative 3x squared plus 2x plus 9 over x squared plus 3 all squared. You can combine these bottoms here because that's really the power of 1. So you have the same base, you can add the exponents. So we're just going to leave it as 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 over x squared plus 3 all to the cube, to the power of 3. And that's your final answer. Whew. All right, let's do one more example, and that'll be it. Sorry about this, is a long video. All right, last one. So f of x is equal to x over cube root of x squared plus 4. Now, we don't like square roots, we don't like cube roots. So I'm going to rewrite it as x over x squared plus 4 to the power of a third. Now, I don't want to use product or quotient rule. I want to use product rule. So what I'm going to do is flip that up. So that's going to become x times x squared plus 4 to the negative 1/3. Now I can use product rule on this. So again, you don't have to go off to the side and do this, but sometimes it helps. I don't usually do it, but I think it has benefits. So we're going to go u is x, and v is x squared plus 4 to the negative 1/3. So u primed is equal to 1, and v primed is negative 1/3 times x squared plus 4. Take away 1, so that's like minus 3 over 3. So I get negative 4 over 3 times the inside derivative, which is 2x. So to clean that up, I'll get negative 2x over 3 x squared plus 4 to the negative 4/3. That's v primed. Okay. This is product rule, so it should equal u primed v plus v primed u. All right, u primed is 1. You don't have to write it, but we did. X squared plus 4 to the negative 1/3 plus v primed is this gong show. Negative 2x over 3 x squared plus 4 to the negative 4/3 times u, which was x. So before I start simplifying it, I'm going to clean it up. The first one is just x squared plus 4 to the negative 1/3. This becomes minus 2x squared over 3 x squared plus 4 to the negative 4/3. All right, so we got to simplify this, clean it up. Now, we can pull that fraction out, the 2/3, okay? Or we can just pull out a third. Let's just pull out a third, see what happens. So 1/3 is going to come out. I'll do this in separate bits. So if I pull a third out, this one gets divided by 1/3, so it's actually 3 times x squared plus 4 to negative 1/3 minus 2x squared, x squared plus 4 to the negative 4/3. Okay, if you need to check, if you multiply the third in, you would get back the line above. All right, so the next common factor that comes out is x squared plus 4, but to what power? Remember, we take out the smallest power, which is negative 4/3. So that means x squared plus 4, the negative 4/3. There's a 3 in there. Now, subtract the exponents. Negative 1/3 minus negative 4/3 is negative 1/3 plus 4/3. Add the exponents, so you get 3 over 3, which is 1. Seeing a pattern here, people? Pretty much always equals to the power of 1. Minus 2x squared. And if you're wondering where that 3 went, it's actually in the denominator, because it's 1/3. All right. Inside here, excuse me, multiply that in, negative exponent, flip it down, so I get 3x squared plus 12 minus 2x squared over 3 times x squared plus 4 to the 4/3. 3x squared minus x squared is x squared plus 12 over 3 times x squared plus 4 to the 4/3, and that is it. All right, here are your practice questions, page 136, 23, 25, 27. Please, please practice. It's the only way to get good at this. All right.